Okay, hi guys, welcome back to my YouTube channel. We are now to discuss the summary chapter 4. Okay, let's start. Chapter 4 is titled Network Access. So to support our communication, the OSI model divides the function of a data network into layers. Each layer works with the layer above and below to transmit data. So managing the medium, you and your colleague are attending in networking conference. Data link protocols govern how to format a frame for use with different media. Excuse me. Types of connection: internet switch, internet connection, and embedded wireless antenna. So for home router, for connection to the wired LAN, connect your computer to the Ethernet port. Then network interface cards connects a device to a network. Ethernet and NIC are used for a wired connection. And then the physical layer, the OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network media. Source node down here, then destination node. Then physical layer media, they have copper cable, signal or patterns of electric pulses, fiber cable, fiber optic cable. So the signal are pattern of lights here, the fiber optic, and the wireless. Physical layer standards, and the physical, then protocols and operations of the upper OSI layer are performed in software designed by software engineers and computer scientists. Then the function, then bandwidth. Different physical media supports the transfer of bits at different rates. So here, throughput is the measure of the transfer of bits across the media over the given period of time. And then we have the type of physical media and characteristic of copper cabling, copper media, and unshielded twister pair cable and shielded twister pair cable. Unshielded is the most common networking media. Cabling terminated with RJ45 connectors is used for interconnecting network hosts with intermediate networking devices such as switches and routers. Then the shielded twisted pair provides better noise protection than UTP cabling. Then coaxial cable get its name from the fact that there are two conductors that share the same axis. A copper conductor used to transmit the electronic signals. Then all three types of copper media are susceptible to fire and electrical hazard. And then UTP cabling. Data link layer. Data link layer allows the upper layers to access the media. Then data link sublayer. Logical link control sa upper sublayer communicates with the network layer. And then media access control or MAC. This lower sublayer defines the media access processes performed by the hardware. Then media access control. Layer 2 protocols, data link layer. As packet travels from the source host to destination host. Providing access to media. Different media access to control method may be required during a single communication transfer of frame. Like this. Packet. The data link layer is responsible for controlling the transfer of frames across the media. So, then data link layer standard. Then we have topologies, controlling access to the media, sharing the media, regulating the placement of data frames onto the media is controlled by the media access control. Then physical and logical topologies. Physical topologies refers to the physical connection and identifies how and device and infrastructure devices such as routers, switches, and wireless access points are interconnected. Physical topologies are usually point-to-point or star. Then the logical refers to the way a network transfer frame from one node to the next. This arrangement consists of virtual connection between the nodes of networks. These logical signal paths are defined by data link layer protocols. Here the logical topology and physical topology. Then common physical one topologies. Here to point-to-point topologies and hub and spoke topology and pole mesh topology. Point-to-point is the simplest topologies that consists of a permanent link between two endpoints. Then hub and spoke topologies, a one version of the star topology in which is central site interconnection branch site using point-to-point links. Mesh. This topology provides high availability but required that every end system be interconnected to every other system. So, and physical point-to-point topology, logical point-to-point, Physical LAN. Physical LAN topologies. Physical topologies define how the end system are physically interconnected. In shared media LANs and devices can be interconnected using the following physical topologies. We have star topologies, extended star topologies, and bus and ring. And devices are connected to a central intermediate devices. Then extended star. In an extended star topology, additional Ethernet switches interconnected other star topologies. Then bus. All end systems are chained to each other and terminated in some form on each end. Then the ring. End system are connected to their respective neighbor, forming a ring. So here, like a ring. So half and full duplex. Then is the half full duplex. And this is the full duplex. So the frame data link layer prepares a packet for transport access the local media by encapsulating it with the header and trailer create a frame. So it's a frame fields here. And LAN and one frame. And chapter for network access. The TCP/IP network access layer is the equivalent of the OSI data link layer. The OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network media. So that's all for chapter 4, and thank you for watching.